Alright, so the question is, are particle physicists in overall agreement with quantum physicists about dark matter and dark energy, or are there other schools of thought? Or is that not something particle physicists are concerned with? So, to answer this briefly, yes, this is the case, because let's just examine the nature of the argument, like where dark matter and dark energy comes from. Well, first of all, dark matter and dark energy are completely different things, and they're used to describe completely different phenomena. So, dark matter is utilized to explain this, which is a galaxy rotation anomaly, you might call it, because you would expect from Newtonian gravity this sort of velocity profile. It's velocity of stars with respect to their distance from the galactic center. So you would expect from the visible distribution of matter something like this, but we observe something like this instead. So the velocities are too big for the gravity, Newtonian gravity, mind you, to keep these stars there. They would be just thrown away by centrifugal force with this huge velocity that they're having. So the solution that people come up with, Zwicky, Vera Rubin, people like that, so they've said, well, maybe there's dark matter. There's matter that we don't see, basically, okay? Which adds a lot of mass. In fact, it's like 3 to 4 times more mass than what we see. That's what we should have according to Newtonian gravity. I once again emphasize this, okay? So this is where dark matter is coming from. Dark energy is a completely different thing. It's used to explain the so-called expansion of the universe, which is, as you may know, we assume the universe is expanding through observations of redshifts of distant objects. So we assume these redshifts are due to Doppler effect, which means the things are receding from us, and it has been found that the farther the object is away from us, the more redshift it has, so apparently it has higher velocity. So apparently the universe is expanding. Now, if you ask me, this is complete garbage, but this is the usual explanation, okay? This is complete garbage as well, if you ask me. If Newtonian gravity doesn't work, you just come up with a better theory of gravity. You don't fix it with putting in 3 to 4 times more matter than we actually see. Like, this is a really bad solution, and it's unfalsifiable in principle, so it's kind of bad. This is kind of bad for other reasons, for logical reasons mostly, but it's the whole relativity discussion, which I don't want to enter into right now for the sake of this discussion. So dark energy is supposed to be this mysterious thing which accelerates the expansion of the universe. And as you can see, dark matter is what attracts things, dark energy is what repels things, essentially. So they're completely different things. And dark energy is working on much larger scales than dark matter. Dark matter is galactic scale, whereas dark energy is cosmological scale, where it's a galaxy is a dot for cosmology, essentially. A galaxy has no size for cosmology. So dark energy is much bigger in terms of spatial scale. So, to return to your question, are particle physicists in agreement with quantum physicists about dark matter or dark energy? It's not even the realm of particle physicists or quantum physicists, as I've shown you. It's the realm of astrophysics, dark matter, and cosmology, dark energy, okay? It's not particle physics or quantum physics, neither of that, actually. However, as you might guess, if cosmologists and astrophysicists first and foremost, because dark energy, we don't know what it is. They say they don't know what it is, but because it's not even matter, it's some phenomenon, if you wish, okay, according to them. Again, I don't even think that it exists, because I think the redshifts are misinterpreted, but let's just run with the normal mainstream narrative. So dark energy is some property of space-time, if you wish, whereas dark matter is actually, supposedly, it could be matter, so it could be particles. So these particles could be detected, and that's why people like particle physicists and quantum physicists are hyped about it. So when astrophysicists come to them and say, well, there might be some other form of matter, particle physicists are excited. They're saying, okay, give me monies. pay me monies. Maybe I will find this mysterious and new particle. That's what they're doing with experiments like this one, for example. So they are pretty much on board, because why wouldn't they be? Particle physicists love concocting new theories, all kinds of stupid and crazy theories about all kinds of stupid and crazy new particles. So they are very excited about dark matter. So that's the longer answer to your question. So yes, in principle, it's not what they're working with in general. However, if astrophysicists ask them to search for a mysterious new type of particle, they are very gladly doing so. So hopefully this answers your question.